So last class, we discussed about the components of motherboard. So there we started with the processor, then BIOS, then CMOS, then slots, and we discussed I/O port or disk controllers, I/O ports and interfaces, and bus. So next what we are going to discuss is the memory. So already we know that computers has the ability to store and recall. So how storing and recalling of data is done means using the computer memory. So now this memory should also be communicated through the motherboard. So there should be some place where we have to keep the memory inside the computer. Then you have to connect communicate with the processor, and this communication is established with the help of bus. As already we know, the CPU fetches data and instructions from the memory and performs the operation, and again it is transferred back to the memory. So now we are talking about this memory. So what are the memories? How the data will be stored in this memory? What are the different types of memory and what are their features? We are going to discuss now. So memory, it's very important in real life also. So as a human, we know how we remember things. So we learn so many things, we see so many objects, everything we see will be stored in the human brain cells. So whenever we recollect, so it helps in identifying. So this is essentially very important to perform any operations, even including humans. If your brain is not functioning, then it is difficult. In similar way, the computer memory is also very important. So if computer memory can hold data, and again you can access whenever you want the data. There are some memory which is stored as long as the power supply is on. There are something electronic devices, electronic components which will be retained even the power supply goes off. Need not be electrical components. Sometimes we have a magnetic material also. So we'll discuss all these things this class. So now, memory is a storage unit. So we are going to store in some electronic devices and magnetic devices. The purpose of memory, whenever CPU wants data instruction means, so CPU can perform only the operations. And also CPU has got temporary memory. You already discussed registers. And this temporary memory is not sufficient to store all the information which we are going to process. That is data, instruction, and also result obtained. So therefore, to store these things, we need another memory, some type of memory, additional memory. So that is what we are going to discuss. So there basically we have two types of memory. One is called internal memory, another we have a external memory. So this internal memory is normally used to hold the data and instruction that is currently needed by the CPU. So whenever CPU executes instruction means, so the data and instruction should be present in the internal memory. So from this memory, the CPU takes the data and instructions, perform the operations, and then again data is transferred to this internal memory. From this internal memory, then it goes to secondary memory. So that is indirectly internal memory means it holds the data and instruction which is currently needed by the CPU. They are very fast, they are expensive, so therefore we have a small size of internal memory. So we have three internal memory. One is called registers, another is called the cache memory, and one more is called the RAM or primary memory. We learn all this one by one. So and also look at this internal memory features, or what are the features of internal memory means. As already I've said, they are temporary storage. The storage capacity is less, limited storage capacity, then fast access and high cost, they are expensive. So these are the features of internal memory. So whatever the internal memory you take, so normally they are temporary storage, they have a limited storage capacity, they have fast access, and they are very high cost. So we'll learn one by one. Let us learn about registers. I think registers already we know. So registers we come across when I'm explaining the components of CPU. The registers holds the data instructions which is currently needed by the CPU. That is, whenever CPU performs execution of instruction means it gets the data and instruction from the cache or RAM main memory, then it is transferred to registers. And it used to store intermediate results, data and instruction. Results also it is used to store finally. And then it is transferred to the main memory. So depending on the size and also number of registers will define the speed or power of computers. If you want to have a powerful computer means we must have more number of registers, internal, that's what we call registers, the temporary storage, and also they should have a higher storage capacity. Indirectly, the register size is also one of the factor which will affect the speed or the power of computers. So there's something about this registers. So next we have the cache memory. The cache memory is an advanced memory. So normally the cache memory, very high speed memory, and also it's very expensive. So why we need this cache memory, additional memory means the CPU's very fast processor. The CPU is a fast calculating device. To cope up with the speed of the CPU, this internal memory, what we are discussing about like RAM main memory, will not cope up with the speed of the CPU. So therefore what we do means we increase the speed of the processor or the system by adding additional memory. The CPU is always faster. So what we try to do means to work with the higher speed, so we supply the additional memory. So this additional memory is called as a cache memory. The cache memories are very high speed memory. So they are very expensive. They're kept between the CPU and the main memory. So normally the processor itself will be having the cache memory. So whenever the CPU execute, so it takes the copy from the main memory and the same copy will be kept in the cache memory. So next time the same data instruction is needed means it takes the data from the cache memory instead of getting from the RAM or main memory. As a result what happens, because the cache memories are fast, the execution of instruction becomes much faster. So that is something about cache memory. There are two types of cache memory. That's a primary cache and also we have a secondary cache. So what is primary cache? Or we have level 1 cache and level 2 cache. So what is level 1 cache means? The CPU resident. Inside the processor we have a cache memory that is called level 1 or primary cache. And also we have between the CPU and the main memory we have a cache that is called level 2 cache. So normally the cache memory will be in smaller in size. That is, they run from 256 to 12 MB maximum. So and also we have a level 3 or secondary cache. This is a motherboard resident. So we use additional chip, the memory chip on the motherboard. So this cache memory is known as secondary or level 3 cache. So when we use level 3 cache, it increases the speed of computer. The cache memory, as I told, it is used to increase the speed of computers. So higher the cache, whether L1, L2, L3, so as a result what happens, the system becomes much faster. So therefore, now what you have high-end systems, they have like i7 processor which will be having L1, L2 and also L3 cache memory. So this is something about the cache memory. So next we learn about the RAM or the main memory. The primary memory is also called as a main memory of computer because it holds everything what is needed by the computers. Like it is used to store the operating system, system software, application software and user data and instructions. Everything will be kept in the main memory. That's a primary memory. So this is stored in the main memory. That is what we have RAM. We'll discuss this primary memory so that CPU can access this RAM quickly. So they are very fast memory. Again, we have a limited storage capacity of RAM, that's a primary memory. So now let us discuss about how this primary memory or RAM works. The RAM primary memory will hold the data and instructions which are currently needed by the CPU. So normally already I have said, so application software, operating system and your data and instruction is also stored in a memory. So that is the CPU wants means, so all this kept in this memory. So the purpose of this primary memory or the internal memory is to make sure the CPU gets the data and instructions whenever it is necessary, whenever the execution becomes necessary. So then we use this primary memory. So we have two types of primary memory. One is called the RAM, random access memory, and one more is called ROM, read-only memory. Already everyone is familiar with the terms RAM, ROM. So now what is this RAM? So RAM is used as a primary memory or main memory of computers. So they have a normally limited storage capacity compared to secondary memory. So what this RAM does means it holds the data and instruction that is currently being executed by the processor, that's the CPU. So this RAM is a volatile in nature. So volatile means they will be retaining data and instruction as long as the power supply is on. Once the power supply goes off, they lose the content. That's why they are called temporary, that is what we call volatile memory, because you might have seen when power goes off suddenly and whatever data and instruction kept in the main memory will be lost. So that's why we use the UPS, uninterrupted power supply. That's the intention, that's the purpose. One reason to prevent data loss during the execution of program, and second one we use the electronic component. So to prevent the hardware electronic component damage due to the power failure. So therefore we use additional power supply that we'll discuss later on. So RAM, that is the meaning of volatile. Volatile means as long as the power supply is on, they'll be retaining the memory. Once the power supply goes off, they lose the content. So one more is called ROM, read-only memory. So this is used to store all the BIOS or booting instructions. Already we know about BIOS, basic input output system. These booting instructions are kept in the ROM. So they are non-volatile. That is, they'll retain the data and instructions even the power supply goes off. So you know what is BIOS. So they used to activate all the hardware so that the execution, the computer ready for its performance, or you can use the computers. It sets the computer ready for the users. It's already we discussed BIOS. So where these instructions are kept means they are kept in read-only. So why we do not use a volatile memory here? Why we use a non-volatile means because we switch off and tomorrow you come and switch on anytime, because if it's a volatile memory, the instruction will be lost. That's why we use a ROM, which is used to store booting instruction. BIOS will always be kept in read-only memory, ROM, which is non-volatile. That is the reason. So this is something about the memory, what we are discussing. So there are different types of RAMs. We'll learn one by one. The first one is DRAM. Then we have SRAM, then we have SDRAM, then we have DDRAM. The first one is called static RAM. So DRAM is most commonly used as a main memory of computer. Most of the computers, they are smaller and also they are very cheap. And it consisting of transistors and capacitors. The transistors are arranged in the form of matrix, rows and columns. And each memory cell, it's paired with transistor and capacitor. Transistors works like switch, so that guides the circuits when the capacitor gets charged and when to discharge or change its state. That is, the retaining one is capacitor is charging. So when it loses its contents, it is 0. So this combination, so it is having 1 or having 0, this combination will decide. So we can store data in the form of zeros and ones. that depending on the transistors and capacitor combination, they are paired together. The switch and it is stores, so that is retaining. So normally what happens, the capacitors are discharged every frequently. Whatever it is get charged, automatically by nature they'll be losing its content. So therefore what we have to do means this DRAM has to be refreshed every milliseconds. As a result of this, what happens, they take more time compared to other type of memory. So normally the accessing speed of this DRAM is from 50 to 150 nanoseconds. Normally what happens, every milliseconds, like in a second, 1,000 times it has to be refreshed. Because of this, what happens, the accessing time. So we have to get data from the DRAM means it takes more time, that is 50 to 150 nanoseconds. So next what we have is called, another is static RAM. The static RAM is very expensive and they are normally used as a cache memory of computers. Already we know about cache memory. So this consisting of 4 to 6 transistors. They do not use capacitors. So only transistors will decide. So because normally what happens, we had the capacitors, they will be losing. So there is no capacitor means there is not necessity of refreshing. So hence the accessing becomes much faster in this synchronous, what we call static RAM, that is SRAM, we call it as SRAM, static RAM, and they do not need refreshing circuit and they are very expensive. They have lesser storage capacity, smaller capacity. The storage is very less, but they are very expensive. Therefore, they are used as a cache memory and they do not need refreshing circuit. This is something about the SRAM. So next one, we have SDRAM. So this is a type of RAM that is called synchronous dynamic RAM. This is a type of DRAM which is synchronized with the CPU clock. So this knows when the next cycle is. So before the CPU asks the data, it gets the ready. So thereby reducing the CPU waiting time, because we know this memory is synchronized with the CPU clock. So it is rotating, CPU knows the instructions and we know this RAM knows exactly what will be the next instruction is needed. So before it asks it and it holds that data and instructions, whatever it is, and then CPU fetches. As a result, what happens, the execution becomes faster. That is something about SDRAM. And one more we have is called DDRAM, that is called double data SDRAM, synchronous dynamic RAM. This is exactly similar to SDRAM, but the amount of data transfer is twice. That's why it is called double data. So the rate of data movements is the double. That's why it's called DDSDRAM, that is double data rate synchronous dynamic RAM. So then we have next is, we discussed about something power supply. So as we know that computer works with powers. So power supply, there becomes it necessary to provide the power. Already most of us we know this electronic component functions with power. So we need to supply power. So normally typically it takes 230 to 250 volts of normally power. So there we have what happens, this computer is made up of many electronic components. They works with different voltage levels. They do not take 230 volts of power, so they need to be supplied with, they have to be converted with the different voltage levels. To do this operations, we have a SMPS, switch mode power supply. So at the back of the CPU, you can see there will be a fan. It's a cabinet, what we call the CPU we may pronounce. It is not a CPU. This entire, the computers, components are kept here, cabinet. So there you can see the back of the cabinet, there is a fan which is making noise. So because this SMPS generates more amount of heat, to prevent this, so we use a fan. Normally whenever you switch on, you'll get noise, the fan noise, that is because of SMPS. So this SMPS is like transformer. It converts AC to different levels of DC. So because each electronic components take different amount of voltage, therefore we need to be converted. To do this operation, we have a SMPS. switch mode power supply. So then what we have means, so depending on the requirement, normally it is 230 of watts, normally the power consumption of this SMPS. And then we have one more important is called UPS, so uninterrupted power supply. Already I have told about the importance of the electricity. Now what happens, there are some electronic component, so when power goes off suddenly, they become inactive. They may not work because they may be in saturated state, and the power goes, suddenly they come back to cut-off state. Example, transistors or some electronic components, bistable device, most of bistable. So sudden decrease in power will make that hardware or electronic component not to function properly in the future. So therefore, what we have to do means, so we have to supply power continuously. To do this, we use that's why we call the uninterrupted power supply. So how this power supply works means there are two types. One is called online power supply, another is called offline power supply. So in offline power supply, what happens means, so whenever the power goes off, so that's UPS means running the power by the battery in the event of power failure. So normally we have a batteries, and when it detects power problems, so then automatically it will be switched to this UPS. So through which through the battery it is supplying the power to the system, so you can store whatever data and instructions in the RAM safely, and they can shut down. As a result, all electronic components will not affected, and also data will be secured because RAM is a volatile memory. So there we have two types. So what happens in offline means, so whenever detects the power problem, then only it supplies the power. So there is a momentary gap. You can notice when if it's offline UPS means, so when the power goes off, you can notice some blink. So that's indication where some milliseconds computer will not accept power. To prevent this, we have an online UPS. In online UPS, what happens means, even the main power supply is working, so this through the UPS also the power is running. So if the main power goes off, because it's continuously running with the UPS through the battery, so the system will not have the momentary lapse of power. The power will be continued, so there is no changes. There will be permanently power supplied. So this is something about the UPS, online and UPS. That's online UPS and offline UPS. So this is actually completes this chapter. I think you can now, at the end of this chapter, so we can make configurations. So and also we know what are the electronic components we needed, and also you can take these components and you can assemble. As we discuss now, the most important component is the motherboard. So already we know ATX is the present motherboard available, and also we have to go for the bus, the size, and also registers, and also we have to think of the processor, what is available. Most important is processor. Nowadays we have i7 processor, which has already we discussed about the importance of processor. And then we have a main memory, and also we should have a secondary memory. So the main memory comes with the 8 GB of RAM, and secondary memory comes with terabyte, 1 terabyte capacity. You can, if you want, depending on requirement, you can increase. And also you can use USB devices, connection devices, and also you look at for AGP port, that is the advanced to run graphic applications, and the ATX cabinet to house all these things. All are plug and play, just you connect them. RAM, it's available, processor is available, just you connect. So you have to take the cabinet, it's where you mount everything. So it takes very simple, but you must know how these components works. So once you assemble these things, you'll understand. I think immediately you cannot go and assemble, but you have a knowledge of doing so. So that's why this chapter is just introduction. If you do practically 1 or 2 systems, just you watch somebody's assembling computers, so automatically you can learn. So you'll be knowing some components and all the specification. So we need, depending on requirement, should I go for 4 GB of RAM? Should I go for 8 GB of RAM? Or should I go for i3 processor? Should I go for i5 processor? Should I have to use i7 processor? Depending on the requirements. Secondary memory, how much should I use? Should I use for only 500 GB or should go for more, 1 TB or more? It depends on how much amount you are going to deal with. So now, should I use multimedia keyboard or normal keyboard depending on the requirement. Shall I use the cordless keyboard? Shall I use a cordless mouse? Shall I use a USB? How many USB devices should I use? The disk drives like optical storage devices, DVDs or Blu-ray disc connectors, or nowadays what we are using. And then now we all are replaced by pen drives. So USB is enough. So this is the configuration. This is the knowledge about the hardware which we are going to use. So people may different people use different computers. At least we have a knowledge about these components. At least we are familiar with some terms. We have abstract level of knowledge about these electronic components. That's all the components of computer. That is the purpose of this chapter. I think you have understood. Most of you have understood. Once again, as I said, read the textbook. In this chapter, the most important things are the abbreviations and types of RAMs. We start with like types of motherboard. So what is the possible question you can expect is, every topic, what I explained, you have to go with everything. I cannot say this is the only important question, this is not important. So this exam, they ask this one. Next exam, they may ask different one. So therefore, do not exclude. Read only this is important, don't read this one. Never do this. Read everything, you will understand. And let them ask any type of questions. Most important, abbreviations, expansion are important. Learn all expansions. And also I said, like, what is motherboard? Types of motherboard, explain any one. We have understood. And then components of motherboard, and then explain any one component, or explain all the components of motherboard. And what is the expansion slot? Mention different types of expansion slots like this. At the end of this chapter, we have an exercise. There you follow all the questions and write the assignments and submit when you come to the college. When college reopens, write this. So 1 marks questions separately, I think most of you know, and 2 marks questions separately, and 3 marks and 4 marks questions. And this is one of the easiest chapter where you can learn. So don't waste your time just, we are doing online. So online means I can watch for 5 minutes and scroll down or do whatever I don't know. Most of you watch carefully. Some of you may not interested. Some topics are not interested, but still have a patience. Go read, at least same thing you listen 1 or 2 times. So by that you'll understand more better. And also take the textbook. So when you take the textbook and you recollect all the videos uploaded, and you can write the answer by listening only. But don't do this, read the textbooks. So that's most important. If you find any points is missing, is not understood, again listen to the video and then write the assignment. So if you have any doubts, you can clarify when the college reopens, and also that's not a problem. I think it's very simple. You go with the textbooks. The most important, I repeated, textbook. There is no other substitute. You cannot use alternative method. Better is textbooks. Read the textbook. If you have doubts, confusions, let me know that, so that we'll discuss in the next class. So this is the first chapter where we learn about the hardware, the electronic components. And that's what we call typical configuration of computers. The important questions, once again I may repeat this, we cannot restrict, don't follow, these are the only questions. All the questions in all the topic what we discuss, they may ask, like they explain about cache memory. I may not told about the different types of DRAMs. They may ask anything like this. So therefore, learn all the topic, all are important only. Every topic you take, you think this possibly question. Like you are reading, what is L1 cache? What is the primary cache? Or what is secondary cache? This is also an example. Or explain different types of cache. This also question. So I cannot say this is possibly they may ask. But learn this, let them ask any type of questions. I hope you will understood better, I think, because I don't say it's a better, but still I believe instead of wasting time without in touch of subjects or books, now it is for a time being, it is a wonderful, really it is good if you follow. So it's very easy, comfortable also for you when college reopens and you come in, so you'll be having all the knowledge about this. I think I'll start the next topic, next class. If you have any doubts, you can send a message. Possibly if anything, any topic so far what we discussed, find it difficult, let me know so that I make one more clip if it's necessary, I'll teach you. I think most of the things I have explained clearly. Still you found it not understood in the textbook, let me know. Otherwise, when you come back to the class, then also you can ask. Don't waste time. Be safe at home and learn these things and listen to the videos, every subject. Not only this, computer science, everyone, all the subject, whether it's a commerce or science streams, please go with the textbook. Read the textbook, note the points and solve the exercise problems and get ready for the next academics. That's when it reopens. Okay, we'll continue.